Good morning. Assalamualaikum. Last class we stopped over here, right? On the example 14.6, first law analysis, we had done on the mass flow rate of air. Okay, we are done with the mass flow rate of the air. Any question on how to get the answer? Mass flow rate of the air, so it means the m air, m dot air. Okay, so the m dot air, we can get it from the equation AF. Okay, AF, we know AF m air over m fuel. So this is the equation. Plug in all the info that we get, you will get the AF ratio. Okay, so the A actual over here we have calculated earlier, okay, in the previous class. From here, AF, we obtain the AF value. Now plug it into the equation to get the m dot F. Okay, so this is the answer to m dot F. Okay, any question from previous class? Okay, I hope it's clear. Now we move to B, which you are required to calculate. What is the B? The rate of heat transfer. Rate of heat transfer from the combustion chamber, the Q. Okay, so we know Q is product minus reactant. Okay, product minus reactant. Wait, I need to. Wait, let me open the table. Do you bring your own table? Properties table? In the laptop. Make sure you bring the hard copy. It's easier to refer. Wait, let me open. Most of the time we'll be using table from A, the ideal gas table. So you can print out starting from table, what is it? A18. Okay, table A18 until table A27. Okay, you can print out that table. A18, where it starts with the other properties, ideal gas properties of nitrogen until A27. Okay, this until this table. These are the common table that we will be using in the class. This one not. Okay. Okay, now to solve question B. I put it side by side. Okay, we know that our product is CO2, CO, H2O, O2, and N2. Okay, so we should list out all the infos for the product and reactant. Our reactant is propane liquid. Okay, we skip first for the heat of formation of propane liquid, because that one I will show the calculation. Okay, because why? Because in the heat of formation, table A27, propane propane liquid, table A27, it is given in propane liquid. But in your question, refer back to your question, it is propane liquid. Okay. On the HF over here, sorry, HF. Propane from table A26. Here, propane, the HF given is for gas. Okay. HF given is for gas. But your question, from the question, propane is in liquid form. Okay, later I'll show you how to get HF in liquid form. Okay, now we proceed with finding the infos for other component. Okay, O2, find out the HF for O2 from table A26. O2, 0. Okay, so fill up all the infos that you required from here. N2, 0. H2O, find for water, water gas. Okay, so this is -2 for 1. Gas. Huh? Okay, CO2, HF. This figure, -393,520. CO, -110,530. Okay, find out the info first. Then this one, H enthalpy at T1500. Okay, where to refer? Where to refer? Enthalpy at T1500 for O2, N2, H2O, CO2, and CO. Where to refer? Which table? Huh? A19, O2. Okay, for O2, we find for A19. Okay, at 1500. So the enthalpy, this one, 49292. Okay, this one is for O2. At T298 for O2, here. Okay, I want you to find out for the rest. try to check which table for N2, H2O, CO2, and CO. Okay, find out the figure for the rest of the gases at T1500 and T298. Find out. Okay, what is the figure for N2 at H? For H at T 1500. 47473 298 47073. 298? 8669. H2O? 57999. 298? Come again? 9904. CO2, Ibrahim, what you get? CO2? 0? 9? 8. 298? Scroll above. Check for 298. Come Jayan, what is for CO at 1500? 5, 4, 557. 298? 517. 298?
8669.
Vinodini, what is CO2 at T298? Huh? What do you get, Ibrahim?
1364.
Huh?
1364.
9364. Okay, do you guys get the same? Anyone get different figure? Yeah. Okay, how about enthalpy for propane liquid at 1500? How do you define it? Do you require it? Enthalpy for propane at 1500. How to find? Huh? Yes. Yes. It is not required because liquid propane is not in the product. It is in the reactant only. 298? Same, right? So, because this is reactant. Okay, now. HF for liquid propane. HF. We know HF. We can obtain the info from table. Which table? HF. A26. Okay, propane is here A26. HF is 1035850. But this one is in gas. Okay, so to find out HF for liquid propane, if in gas, it is equivalent to LHB. Remember? LHB. If in liquid, it is HHB. Remember? Okay, this one just extract out the info first. Huh? Okay, this is equivalent to LHV because in gas form. Okay, we want the HF in liquid form. So in liquid form, it is HHV. Okay, remember the equation to find the HHV when you have phase change. I'll show you the slide. Here, LHV plus NHFG of the component. In this case, it shows water, for example. Okay, so this equation is required to find the HF for liquid propane. We are required to find the HHV. The HF given in A26 is LHV. Okay. Now, using this equation, and HFG of the propane. So where to get this info? From table A27. Propane. Okay, propane. Now it is in liquid. The phase here is in liquid. The HFG is the enthalpy of vaporization. Okay, so this figure 335 is the HFG. HFG. This is the M. M is the molar mass. Okay, we extract the info first. LHV is this one, the earlier part. M is the molar mass. Okay, multiply by HFG. HFG over here is 335. Okay, try to calculate what you get. What do you get for HHV? Huh? 89. Xavier, what you get? HHV. 89. That is not in the range. Wait, how about the rest? Vinod, you tell what you get? Same, 8, 9. Huh? What you get just now? 8, 9. Negative or what? Negative 8, 9. 8, 9. 0, 7. 7. 8, 9, 0, 7, 7. 8, 9, 0, 7, 7. Okay, the unit will be in kilojoule per kmol. Wait, let me check. It should be negative 118. What? Okay, the answer should be 118. So, let me see. It is the sign over here. If minus, you will get negative 118. Let me highlight. Okay, here, if negative sign, it will be negative 118 something. Perhaps due to the sign for the enthalpy of vaporization. Okay, this one let me check again on the sign, but the answer should be negative 118. Okay, the figure is negative 118 something. Let me confirm on the sign first. But the equation that you need to use is this one. Heat of, because that one is on gas phase. Heat of formation in gas phase. So now you want to find for heat of formation in liquid phase. Okay, I go back to this slide. Okay, here. The heating value. This one, it use water as example. Now, LHV is in vapor form. Now we want to find in liquid form. So in liquid form is HHV. Okay, so that's why we are using LHV from the vapor form plus the molar mass multiplied by the enthalpy of vaporization here. Yes. Okay, so basically this is the equation that you need to use to find the HHV for liquid propane. Okay, let me confirm on the sign, but the final figure should be 118. Okay, here, 118. This one is from previous lecture. 118, around this figure. Okay, 118622. So putting the infos inside the table. Okay, this is the figure that we are looking for the heat of formation liquid propane. Okay, once we obtain the info over here, then only you can plug in into the equation to find the Q. Okay, so from here, summation of product side minus by reactant side. So product, you have here CO2, CO, H2O, O2, and N2. Okay, so we do it one by one. Product, mole of CO2, 2.7 multiplied by heat of formation of CO2. Okay, this figure. Plus heat at 1500. Okay, which is this one. Minus heat at 298. Okay, this one is for CO2. Do the same step for the rest of the product. Okay. This one is for product. Now do the same with the product, the rest of the product, then minus the reactant. Where your reactant is the propane. Propane is 1 mole, so 1 multiplied by the HF plus this one no lah. Okay, no sensible heat. Okay, then plus the reactant. Reactant here O2 and N2, there is no heat of formation, so remain only the liquid propane. Okay, so list. I will advise you to do step by step so that you don't miss out the numbers. You can calculate correctly. Product list out. This one is CO2, then add on for CO, H2O, O2, and N2. Okay, put in bracket, then minus for the reactant. This is the reactant part. Okay, from there, the final answer would be this one. Negative 397.793. Sorry, no, it is not this one. Because this one is using gas. This one is gas. This is not answer. That one is not the final answer. Wait. The final answer would be, where is it? Okay, this is your final answer. For the Q, kilojoule per kmol. Then to find the Q dot, multiply by, divide by the molar mass to get the kilojoule per kg, then multiply the rate that you are given earlier. Okay, so for Q dot, this is the final answer. Okay, try to calculate it first. Make sure you get the correct figure. Okay, let me clarify something. Why we did not include O2 and N2 in the reactant? Here, just now I just put 0 because why 0? Because heat of formation is 0, O2 and N2. Then the sensible heat, there is no sensible heat for the reactant. Sensible heat is temperature at specific temperature minus enthalpy at reference. Okay, in this case, our inlet temperature is at 298 and equivalent to 25 degrees C. This is the inlet. Okay, so similar at the same temperature as reference. So that's why there is no sensible heat. Let's say your inlet, okay, for example, let's say your inlet enter the combustion chamber at 17 degrees C. So your reactant will have sensible heat. Okay. Again, I repeat, if your inlet enter at 17 degrees C, so your reactant over here will have sensible heat, where sensible heat is H at that particular temperature minus heat at reference. Heat at reference is most of the time will be 25 degrees C. Okay, so that's why in the next chapter, there are example inlet at different temperature from reference. Okay, that's why I asked you to bring the properties table in next class. we will move into more calculation using the properties table, where you have the adiabatic flame temperature, okay, different temperature for the inlet, different temperature for the outlet. Okay, clear? Why this one I put 0? Not only because of the HF is 0, it's also because of no sensible heat. Reactant enter at 25 degrees C. That's why no sensible heat. Okay, clear? Okay. Okay, so we are done with first law analysis. Any question? As of now, the reactant enter at 25 degrees C so far, the example. In next chapter, there will be various of temperature. Okay, this is the starting point. Make sure you understand this part first. Okay, if you still confused, try to watch the recorded session, and if you need my consultation, feel free to message me in Teams. Okay? Okay, any question before we stop? If no question, I stop here. See you. On Tuesday will be your midterm. Don't forget. That's all. That's all. Class hour 12:30 to 2. Equation will be provided. But for the A, the simple one, you need to memorize lah. A, how to calculate the A, right? Yeah. Okay, so that's all for today. Thank you.